Let us find condition of concurrency of three lines. Concurrency of three lines. Let me change the color. Now the three lines that I am considering are a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0, and a3x plus b3y plus c3 equals 0. Now when are the lines concurrent? When they pass through a single point. Let us say this is the point of concurrency. Okay, these three lines, let us name these lines as L1, L2, L3. These three lines pass through the same point here. Now in other words, can I say that the line L3 passes through the point of intersection of these two lines L1 and L2? Yes, technically I can say that, and that will help me to find the point of the condition for concurrency of these three lines. So what will be the point of intersection of L1, L2? Point of intersection of L1 and L2. So if I write it like this, x, y1 and then a1, b1, c1, right? All of us know how to solve these equations by cross multiplication method. So here I will write x divided by, then I'll write b1 c2 minus b2 c1, b1 c2 minus b2 c1 equals y divided by, then I'll ignore this column, right? So y divided by c1 a2 minus a1 c2, or you can say c2 a1, right? And in the end 1 divided by a1 b2 minus a2 1, a1 b2 minus a2 b1. So this will give me x and y. So x will be equal to b1 c2 by b2 c1. Sorry, x will be equal to b1 c2 minus b2 c1 divided by this a1 b2 minus a2 b1. How did I get this? I am equating this and this. Now I'll equate this and this to find y. So y will be equal to c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. Now this x and this y gives me the coordinates of the point of intersection of L1 and L2, and it also lies on L3, right? Because L3 also passes through this point. That is how these three lines are concurrent, right? So it will also satisfy this line L3, right? So let me put this point in line L3. So what is line L3? A3x plus B3y plus C3 equal to 0, and this point of intersection of L1 and L2 will satisfy this equation. So let me put it here, A3 and then this value of x, B1 C2 minus B2 C1 divided by A1 B2 minus A2 B1 plus B3 C1 A2 minus C2 A1 divided by A1 B2 minus A2 B1, and then in the end C3 equals 0. Now when I further simplify it, I'll get A3 B1 C2 minus B2 C1 plus B3 C1 A2 minus C2 A1 plus C3 into A1 B2 minus A2 B1, and on the right hand side I'll have 0. Now this expression is the required condition of concurrency of three lines, and I can write it neatly in form of determinant. The students who know about determinants can write this as A1 B1 C1, A2 B2 C2, A3 B3 C3, and this value of this determinant will be equal to 0 for the lines L1, L2 and L3, which are A1x plus B1y plus C1, and similarly L2 and L3. So for these three lines to be concurrent, okay, this determinant, value of this determinant should be equal to 0, and this is the condition of concurrency of three lines. Okay, and there can be another condition of concurrency. If I take lambda 1, lambda 2 and lambda 3, which are not all 0 at the same time, and put them like this: lambda 1 L1, lambda 2 L2 plus lambda 3 L3, and put it equal to 0. This is also another condition of concurrency, where L1, L2 and L3 are equations of the lines that we were discussing. So let me write a question for you. Find the value of lambda if the lines, these given lines, are concurrent. So if these lines are concurrent, then the determinant 3 minus 4 minus 13, 8 minus 11 minus 33, 2 minus 3 lambda will be equal to 0. Now when I solve this determinant, I'll put that solution or the value equal to 0 and find value of lambda. So let me solve it first. 3 into minus 11 lambda minus 11 lambda minus 99, right? This minus this. So minus minus plus 4, 8 lambda minus 66, minus of minus 66, that is plus 66, minus 13 minus 24 plus 22, that is minus 24, minus of minus 22 plus 22, and I'll put it equal to 0. So now let us calculate. This is minus 33 lambda, and this is minus 3 into 99, that is 297. This is plus 32 lambda and plus 264, minus 24 plus 22 is minus 2. So minus 2 into minus 13 is plus 26, and it is equal to 0. So now solving it further, 32 lambda and this is minus 33 lambda, so minus lambda. This is 264, 270, 290. So 290 minus 297 is minus 7, and we will put it equal to 0 for the lines to be concurrent. So this gives me lambda is equal to minus 7. This is what I wanted to find out. Alright, so this was a question based on concurrency of three lines. Alright, this is it for this lecture.